Okay, so in this video, I just wanted to talk to you about self-ionization of water, okay? Now, water is a covalent substance. You wouldn't expect water to conduct electricity because there aren't any ions present in covalent compounds. But we know that water does conduct electricity, and that's evidence, if you like, for this self-ionization of water, that there must be some ions present in water. Now, the degree of ionization is very small, so there isn't many H plus and OH minus ions, but there are some. And the fact that there are ions present helps water to conduct electricity, or allows water to conduct electricity because it carries the current, okay? Now, you need to know about Kw, which is the ionic product of water. Now, what ions are formed from self-ionization of water? Hydrogen, H plus ions, and OH minus ions, okay? So that's the ionic product of water, H plus and OH minus. Now, at 25 degrees, the ionic product of water is 1 by 10 to the power of minus 14, okay? Now, because water is neutral, what does that mean? Well, it means that this and this is the same. So what's inside the brackets are the same. So I can rewrite that expression, okay, as hydrogen ion concentration to be squared equals 1 by 10 to the power of minus 14, because that's what the Kw is, remember. So the Kw at 25 degrees is 1 by 10 to the minus 14. That is equal to hydrogen ion times OH minus ion concentration. But because what's inside the brackets is the same, I can rewrite that as hydrogen ion concentration to be squared. Now, to get rid of the square, I square root both sides, okay? So the square root of 1 by 10 to the minus 14 is the hydrogen ion concentration, all right? Now, the hydrogen ion concentration then, okay, so hydrogen ion concentration, the square root of 1 by 10 to the minus 14, so that's 1 by 10 to the minus 7. And when I fill that hydrogen ion concentration into my pH formula, then you get out a value of 7 for water at 25 degrees, okay? Now, when you look up values, Kw values in your book, you'll see that the Kw 25 degrees is 1 by 10 to the minus 14. The Kw at 50, so that's 25 degrees. At 50 degrees, the Kw value is 5.48 by 10 to the minus 14. And at 100 degrees, it's 51.3 by 10 to the minus 14. So as you increase the temperature, what's happening to the value of Kw? The Kw value also increases, doesn't it? The numbers are getting bigger as you increase the temperature of the water. So we need to now know Kw, remember, is with water ionizes. So it's hydrogen H pluses and OH minuses here, okay? So we need to figure out now about the forward reaction. Is the forward reaction indo or exothermic? So what's the stress? So stress is an increase in temperature. As a result of that increase in temperature, the reaction is driven over to the right because the Kw value increases. There are more H plus ions and more OH minus ions present. Okay, so if the temperature increases, the Kw value increases, which means that the equilibrium is moved to the right. Okay, that's the stress. What does the reaction want to do? The reaction wants to relieve the stress by decreasing the temperature. How does it decrease temperature? It moves over to the right. So the forward reaction here must be endothermic. Okay? So just to run over that again now. As the temperature increases from 25 to 50 to 100, the value for Kw increases, which means you have more H pluses and more OH minuses, more ions, okay, present. So if you increase the temperature, the equilibrium is driven over to the right-hand side. Why is it driven over to the right-hand side? According to this chat here, to decrease temperature. So the forward reaction must be endothermic. Also, they might ask you, if the Kw value at 100 degrees is 51.3 by 10 to the minus 14, what would the value for pH be for that? Well, Kw is the ionic product of water. That's H plus and OH minus, okay? And that's equal to 51.3 by 10 to the minus 14. It's pure water, so what's inside that bracket's the same. So its hydrogen ion concentration to be squared is 51.3 by 10 to the minus 14. Square root both sides to get rid of the squares. So the hydrogen ion concentration then is the square root of that. The square root of 51.3 works out to be 7.16 by 10 to the minus 7. So that's the hydrogen ion concentration, okay? When you fill that into your pH formula, minus the log, 7.16 by 10 to the power of minus 7, you get a pH value of 6.14. Now, they might say to you, does that mean that water is acid at because it has a pH value of 6.14, does that mean that water is slightly acidic at 100 degrees? No is your answer. You do not turn water into acid by boiling it to 100 degrees. It's still neutral, okay? Now, how come it has this value? It has that value because as you increase the temperature, you're increasing the degree of ionization. So there are more H plus ions. But the really important thing to say in your answer is that there are also more OH minus ions because you're driving the equilibrium over to the right. You are producing more H pluses, which gives you the value of 6.14 because there's more hydrogen ions. But because you also have the same amount of OH minus ions, the solution is still neutral. It's only, if you have an acidic solution, your hydrogen ion concentration is always greater than the OH minus ion concentration if it's an acid. So in acidic solution, hydrogen ions would be greater than OH minus ion concentration. But if it's neutral, lads, then the hydrogen ion concentration is the same as the OH minus ion concentration. And when you increase the temperature, yes, you do have more H pluses, but you have the same number of OH minuses. So water is still neutral at 100 degrees. Thank you.